On the first part of lesson 5, we're going to try to use a string and a pencil to construct all the perpendicular bisectors for the triangle in your book. So go to the triangle in your book. And here we're going to take a string and a pencil, and we're going to try to use the string and the pencil as a compass. So you're going to make a makeshift compass out of the string and use the material to construct the perpendicular bisectors of the three sides of the triangle. So just like we did with the compass, we're going to do this here. So I'm going to use my thumb as the point of my compass. So I'm just going to block off right there my string so it won't stretch any further. I'm going to put my pencil in the loop that I've created, and I created this loop by just wrapping the string around my pencil and then tying it, and then whenever I pulled it off, it made this loop that stayed there. So back to what I was doing here. So I'm going to take and put my pencil in here, and I'm going to draw the arc. Then I'm going to move it up, not changing the width at all. I'm going to make an arc there, go to the other intersection, and make an arc. And there I have two intersections. I'm just going to grab the edge of my sticky pads here and line it up with the vertex and the point of intersection there. And there is my first angle bisector. And it's a little off because I'm using a string. See if I can draw that just a little bit better. Okay. Again, it is going to be just a little bit off because this is a string and not a compass. Now I'm going to go to my second angle. I'm going to do the same thing. So I'm going to keep this kind of short. I don't want to go too big because my triangle is not very big. And notice it does stretch a little bit whenever I put my pencil in there. So that's going to also throw this off. Let's try to get this pretty darn small. So I'm going to stay in the corner. Okay. There's my first arc. There's my second arc. Not changing the distance right here. And here is my, I can get my pencil through my loop, my third arc, and draw that perpendicular bisector. So starting at this point, going through that point, that intersection. There's my second perpendicular bisector. Now do this to my third corner. So put my finger right on the vertex with it pretty darn short. Move it over to my intersection, make my arc. Move it over to my other intersection, make my other arc. And then line up my sticky tab to my vertex and my intersection. And it actually came out pretty good. I have one point right here where all three angle bisectors intersect at the same place. So the question is, how did using this tool differ from the compass with a straight edge? So if you're in class, you'll be stopping and discussing this for just a moment. And then compare your construction with that of your partners. And did you obtain the same result? Meaning you and your partners, did you all get the same thing? So hopefully after you've conferred with your partners, you figured out that all of you, if you did the angle bisectors right, came out with one point where all three angle bisectors intersected at the same place. And it didn't really make a huge difference whether you use a compass or the string. The compass will be slightly more accurate than the string because the string does stretch, and you're not 100% sure that you're keeping that string at the same distance, so your circles are at the same radius. So for this lesson, we're going to break this into 2 days. Day 1, we're going to do perpendicular bisectors of a triangle, and we're going to learn all about what the name of that point we just found was. And day 2, we're going to do angle bisectors and give that intersection point a name too. So some of the definitions we need to work with are angle, circle, perpendicular line, parallel line, and line segment. So in your book, you'll find that it's got some fill-in-the-blank stuff underneath how to using this tool differ from the compass. Hopefully you filled something in there. So when three or more lines intersect in a single point, they are called concurrent lines. And the point of the intersection is called the point of concurrency. So our angle bisectors we just drew were concurrent, and the point we put in the middle of our triangle was called the point of concurrency. Take a moment, get that into your notebook. So we saw in the example of concurrency in yesterday's problem set, when you did the opening exercise with the string, and when you did your homework, the practice set had you find this point also. So all the three of the perpendicular bisectors pass through a common point. So that's the point of concurrency again. And of the point of concurrency of the three perpendicular bisectors has a special name, and the special name is called the circumcenter of the triangle. So perpendicular bisectors make a circumcenter. And we're going to have four different centers of our triangle, so you can never just say the center of your triangle. So the perpendicular bisectors intersect in something called a circumcenter. And it really doesn't matter what type of triangle you have. Certain types of triangles will have the circumcenter on the outside of the triangle, and the one we did, it was on the inside. And there's a possible way where you can get it where it'll be right on the longest side of your triangle. So there's going to be three different ways your circumcenter will happen, and you're going to take your picture you just were working with, and you're going to label that circumcenter P. That way we can talk about it. So take that circumcenter in your diagram and label it P. So if you turn your page, you'll see this exact picture on the top of the next page. It's already labeled P for you. And what we want to do is we want to take and label all of our right angles, and I'm going to make mine red so you can see them, so it color codes. So right here is a right angle, and I'm drawing the little box because the little box means perpendicular, and perpendicular means that they meet at a right angle. And so there's a right angle also. So we've got three right angles. This line here, this perpendicular bisector here, and this perpendicular bisector here. And then we are all going to take and label the congruent segments. So this congruent segment and this congruent segment. And here we've got B to our midpoint here, and our midpoint over to C is congruent. And A to this midpoint is congruent to this midpoint over to C. So we got A to this midpoint, A to that midpoint, and BC has a midpoint with congruent segments on all the sides there. So the point of concurrency of the three perpendicular bisectors is the circumcenter of the triangle again. Just make sure we have that. So what we're going to investigate is why the perpendicular bisectors pass through one point. Does this always happen? What if it's a right triangle? What if it's an obtuse triangle? What if it's an acute triangle? Will it work for all of those? What if you just make the triangle bigger? What if you make it really tiny? Will any of that affect the fact that we have a concurrent lines with a point of concurrency called a circumcenter? So remembering back to lesson 4, we had this picture here, and we had perpendicular bisector here. So this CE was perpendicular to AB, and it bisected AB. So CE was our perpendicular bisector. And what we noticed was point C was equidistant, was the same distance to A and B. Point D was equidistant, or the same distance to A and B. And point E was equidistant, the same distance from point A and B. And we came to the conclusion no matter where we were on this perpendicular bisector, no matter where we were in the perpendicular bisector, we were going to be the same distance to A and the same distance to B. So keeping that in mind, we've got our perpendicular bisector picture here. And I've just copied it over and taken out the perpendicular bisectors and left P where it belonged. So P would be equidistant from A and B. P has to be the same distance to A and the same distance to B and I kept this perpendicular bisector, that's my green dotted line here, because P is on that perpendicular bisector. And so if P is equidistant from A and B, since it lies on the perpendicular bisector of AB. So we have in fact proved that AP and PB have to be the same length. Likewise, we know P is, well, P to B and P to C are the same length, and our special word for being the same length was equidistant. So P is equidistant from A, or P is equidistant to C and B, since it's on this perpendicular bisector. So this perpendicular bisector right here is the one I've kept in this picture over here to kind of cue you in on where I'm talking. Therefore, P has to be the same distance to B, to C, and A. Because it's the same distance to A and B, and it's the same distance to B and C, then it has to be the same distance from C and A. Kind of works that way. So AP, BP, and CP are all the same measure, the same length, which suggests that P is the point of, and our word that we're learning right now is concurrency of all three perpendicular bisector. Point of concurrency. BP, CP, and AP are all lines of concurrency, are concurrent lines, and this is a P point of concurrency. And that is the end of day 1.